Welcome back. This is Sachin again, and today we'll be talking about centralized outbound routing to the internet. So, as the name suggests, basically consider that you have multiple VPCs and you want internet connectivity, and you do not have all the VPCs have like internet gateway or NAT gateway, but there is a one centralized VPC which you want to leverage for the internet connectivity from all the VPCs. So this video actually simplifies whatever has been discussed into documentation. So let's get started. So even before jumping directly to what exactly is centralized VPC and when and why we should use it, let's understand the problem. So this is a typical architecture in any cloud. So consider that you have a VPC and in one of the region, and like VPC is a private area where by default there is no connectivity, internet connectivity from outside. Of course, unless you allow that. So this is like basically a secure logical separation, and this is like into Amazon private zone, and there comes the Amazon public zone. Here all the services like S3 or SQS or SNS, all these will be available over there, and typically the internet connectivity is needed to access these services. And after this public zone, now comes the public internet, where like all the website or anything like publicly you want to access, like www. For example, example.com. All right, so let's quickly focus on the VPC side. And if you want high availability in your VPC in that particular region, you would like to have at least two, bare minimum two AZs. Let's call them AZ A and B. And you have, let's say, public subnets, which I'm depicting into this green box, and then private subnet, where you would like to have your secure application, like any EC2 instance where your application is running, or database or whatever. Okay, and I just want to mention one point why this a subnet is called a public subnet, because the route table, the default entry for 0.0.0.0/16, /0, that default routing is via internet gateway. So basically anything which is within a local or VPC should locally resolve it, but for anything it should go via internet gateway. And so the moment you make this a public subnet, which means the internet connectivity is available, which not only means that the connection can be initialized within the subnet, and via internet gateway you can access either your public Amazon services like S3, SN in this case, or via a public internet like www.example.com. And at the same time, if anybody, any program, machine, or human from outside wants to access some services in public subnet, it can also do via internet gateway and access it. Of course, your security group should be allowing this. As long as your security group allows, this will be accessible. Now there comes a special service called NAT gateway. Okay, so at many times you do not want your services to be exposed to internet, which means the connection person sitting from outside should not be able to access these, and they not only a security group, like they should be blocked by default. However, at times they want to access internet, like this connection should be stabilized first from these applications which are like in the private subnet, and for that you need a NAT gateway. So the similar way the default routing was for internet gateway, you must place, point number one, your NAT gateway or NAT instance into a public subnet, point number one, and point number two, the default routing 0.0.0.0/0, the routing should be to the NAT gateway. So far so good, all looks good. As long as you have a VPC, you can access your Amazon services or public internet, and also you by default on network you have blocked any connectivity in your private subnet, and this is highly available also. So this is a typical architecture, but the problem arises the moment you start building more and more VPCs. So consider this scenario. Now this shows 3 VPCs, but typically you can have hundreds of VPCs in your project or applications. So this is so far this is also good in all these VPC, VPC1 and VPC2 and VPC3. All you have done is like, start duplicating the whole thing, which means you have internet gateway here and then NAT gateway, 3 NAT gateway, one in each one, and public and private subnets. This looks good as long as you have a requirement like, you want internet gateway and want to reach an application in a public subnet, but typically most of the time this is not desirable. Your many VPCs, you want to have an internet connectivity which should be which should be initialized within, but you do not have a requirement for internet gateway and NAT gateway. And by the way, these are costly. NAT gateway is costly, and I believe so do internet gateway. And just to access internet in each of the VPCs, you do not need these things, and that's where the centralized outbound internet architecture comes into the play. So if we just want to summarize this, this has more admin overhead because you are managing these ones. So I just pointed out 1, 2, 3, and 4. These are like most of the time they're not required. You do not need internet gateway, you do not need NAT gateway. They are costly. It shows many route tables, might not be needed. And in case if you do not want a public subnet, we don't have to create that. And definitely, we already covered that this is not cost effective. So what is the solution? The solution lies into this portion. This is exactly the same which I have shown you in this document. I will be putting all these links. So this is a typical architecture where VPC is basically acting as a centralized outbound point for internet, because this has internet gateway and a NAT gateway, which is in a public subnet, and all these VPCs are connected with a transit gateway. So let's quickly see it in this diagram, which I have drawn in more details. So let's understand it. So this is VPC1. Its CIDR is like 10.1.0.0/16, and it has typically private subnets, public subnets, internet gateway, and NAT gateway, route tables, so on and so forth. And by that, these applications, let's say, which are in a private subnet, they want to access any Amazon services, public services like S3, SQS, and SNS, or even a public internet, they can do so. But now there are two more VPCs down here. You can see this is VPC2 here and VPC3 here. They want to access internet, but I do not want to create all the VPCs this internet gateway or NAT gateway. How we can do that? The answer lies into a transit gateway. So on transit gateway, I've already placed a couple of videos how within a region or how inter-region you can create the connectivity between them. And this is AWS recommends to use transit gateway over VPC peering to connect to VPCs. I will place the link. You guys can go through that. But here the problem we need to solve is how to have internet connectivity in all these VPCs using transit gateway. Perfect. So now you can see, unlike this VPC1, in VPC2 and in VPC2 and in VPC3, we do not have an internet gateway like this. We do not have a NAT gateway. In fact, we do not have a public subnet in VPC2 and VPC3. All they are connected it with the transit gateway, where basically these lines are denoting the attachments, and you attach this transit gateway with all three VPCs. All right. In all these three cases, now let's focus on the route table for a typical architecture for VPC1, where anything for this CIDR range, this should resolve to local. Of course, for 10.2 and 10.3, this is going to the transit gateway. If you have to access any IP in this range for this VPC, VPC2 or VPC3, this should be using this transit gateway. Perfect. But to access anything, for example, you want to access www.example.com, this should go via NAT. So if this application here in this EC2 instance want to access this IP address via route table, these entries, it should reach to NAT gateway, and NAT gateway is in a public subnet, and that's where it gets a public internet connectivity. Now, how the other VPCs can get that? All they need to do is like their local VPC IP range, they should resolve locally. However, for anything, they just need to go to Transit Gateway. We'll come back how Transit Gateway will route it to the internet. But for now, let's understand for VPC2 and VPC3, both the same thing. For any IP range, they should just reach to Transit Gateway. Okay. All right. So now once we reach into a Transit Gateway should leverage this internet gateway to route the traffic to internet. And for that, the route table entry for the Transit Gateway, you must tell that for any CIDR range 0.0.0.0/0, it should reach to VPC1. So this resource ID, this is for VPC ending with 0E. This is basically the VPC ID for VPC1. And that's how if a guy or like an application sitting here in EC2 access www.example.com, which translates into any IP, this consult to the route table and says, okay, fine, this is not a route for within VPC. Let's go via Transit Gateway, and in this Transit Gateway also it consult to this routing and it routes the traffic to VPC1, and that's how these all VPC2 and VPC3 gets internet connectivity. I also want to highlight 2 points over here. Point number 1, as long as you create these attachments, the IP address, this CIDR range for these attachments. So you can see here there are 3 attachments, for one for VPC1, one for VPC2, and one for VPC3. The route type is propagated. Basically, you don't have to manually create them, as in when you create these attachments, these entries are made automatically. So if you want to like more details, as I said, I have already covered Transit Gateways in my previous videos. I'll be putting the link. Please refer to that to understand this point in more details. Now, only thing which is static which we need to create is basically this entry. This is a manual entry which you need to create because it's static, it will not automatically propagate, and that's it. And as and when all these entries are made, all these VPCs will get their public connectivity. So let's understand it with a demo. All right, so I will be placing the link for this GitHub. All you need to do is check out this code, and they are like Terraform files. You might have to adjust some of the Terraform variables. They are like specific to my use case, the region and this image. You might have to change. There are few are not being used, but somehow they are just not clear this project very nicely. But all you need to do is to change your AMI image and region, probably a few more possibly. But yeah, of course, keep your name. You must have to use your own keep your name, but these are not in use, so you can just ignore them. Anyways, so once you check out this project, this is the full architecture diagram. By the way, I've already covered the brainboard in detail, where you can drag and drop and design this component over here, and it'll start creating all your Terraform files over here. All I have done is I have designed it over here, exported this diagram, and committed everything into this GitHub repo. This link I will be giving it to you. Just check it out. Consult this diagram if you have to adjust these variables, and just do a Terraform plan and Terraform apply. Anyway, let's do that. So I have already checked out this project, and as you can see, it is inside AWS Infra and 016. Please bear with my naming convention. I just arrange it based on some numberings and all that. Anyways, so you just list down and you will see all these files over here. Terraform plan. Let's see what all it needs to create. Okay, so it says 29 to add, 0 to change, 0 to destroy. And let me go to my existing dashboard, and right now I'm in my EC2. I refresh, there is no running instance. Let me go to my VPC, and I see I have only one VPC in Singapore region, which is nothing but the default VPC. So typically there is nothing extra, and let's quickly create the whole architecture for VPC 1, VPC 2, VPC 3, and these EC2 instances. Okay. So all I'm gonna do here is Terraform apply, and I know what I'm gonna do here is so auto approve. Okay, so this is going to add these resources into AWS, and I think typically my experience takes like 2 to 3 minutes. So let's do one thing. Let's pause this video, and once this is up, we'll resume that. All right, so I see that it took approximately 2 minutes and all the 29 resources are added. Everything looks green. So let's go to my console, and I'm still on that page where there's showing one VPC default. Let me refresh it. And fine, now I see there are 3 VPCs, VPC underscore 1, 2, and 3 created typically for 1, 2, and 3, where 1 is the one which I'm going to use for centralized outbound because it has an internet gateway and NAT gateway and so on and so forth. And this VPC 2 with this CIDR range, and VPC 3 with this CIDR range. And that we can see over here. Let me sort it by this. VPC 1 is 10.1, VPC 2, 10.2, and VPC 10.3, 00/16. Perfect. Let's go to EC2 dashboard also. Now I see there are 4 instances running. Why 4? Because I'm running like one in public over here and one in private, and then these 2 subnets are private. They're not for like I have one subnet in VPC2 and one subnet in VPC3, and one instances running over here. So anyways, there are 2 instances running in VPC1, one in public and one in private. So I can go to public, SSH into public, and then I go into private subnet, and then I can access to VPC2 subnet, one EC2 instance, and then VPC3, one EC2 instance. Let's do that. So let's catch VPC1. There's a public, so that's why it has a public IP. So catch it. Let me open a new window. Okay, SSH, and I'm gonna go here, say yes, and now I have reached over here 10.1.0.1.6. By the way, this is into a public subnet, and of course I will have public connectivity. I have anyway SSH from my system, so it has a public connectivity which I verified by pinging google.com. Now I'm gonna do here is from this public EC2 instance, I'm gonna go to private instance, and that's why you see there's no public IP address. Copy this, SSH, enter. Oh, sorry, SSH this guy. Yes. All right, now I'm inside 10.1.1.157, which you can validate with this private IP. So now I'm in EC2 instance of a private subnet. Please, I want to repeat again that in this diagram you see there are 2 private subnet and 2 public. In actual, when you deploy this is only one public subnet and one private subnet, one EC2 instance in each one of them. And here there is a one private subnet and one private subnet in VPC3 and one EC2 instances in each. This diagram is a typical, I just wanted to show you very high available, but this demo you don't have to, just want to show the concept that how the outbound internet connectivity works. Anyway, so right now I'm in an EC2 instance of a private subnet. All I'm gonna do is to show you that pinggoogle.com works even if it's a private EC2 instance, because the traffic goes via NAT gateway, and that's why we have public connectivity. Now from 10.1 I'm going to 10.2, basically this VPC. So I'm gonna say SSH, and let's grab the IP address of private EC2 instance in VPC2. Click this, and that's how you can verify it. It starts with 10.2. SSH this guy. Yes, I can go inside, but if I say pinggoogle.com, it doesn't work. It is stuck over here. I'll come back to this, but let's note it. Now again I'm going to 10.3. So now you see because I have connected with Transit Gateway from any VPC to any VPC, I can SSH because the connectivity within the VPC is already stabilized using Transit Gateway and Transit Gateway attachments. All right, so SSH and then, oh, sorry, no, SSH and then let's grab the IP address of EC2 instance in VPC3 private subnet. All right, now I'm inside VPC3, and here also if I say ping google.com, this typically doesn't work. So which means still there's not a public connectivity stabilized, and the reason being is let's go to VPC. Okay, route. So I just want to show you the route tables for all these private subnets. So this is VPC1. So let me open this, and this. Okay, give a couple of seconds. All right, so this is a route table for VPC1, and that's where you can see 10.1 is a local, but 10.2 and 10.3 both are going to Transit Gateway. So anything within 10.1 it should resolve locally, but for 10.2 for VPC2 or VPC3 it should go via the same Transit Gateway. So that's why you see Transit Gateway with the same ID. However, for internet it should go to NAT Gateway, and that's where when I was in this EC2 instance for 10.1 I had a public connectivity because we can see the route is directly to the NAT Gateway. However, if I go to VPC2, and that's where you see 10.2 is resolving locally, but for anything it should go to Transit Gateway, which means from VPC2 we understand that anything locally should go local, but for anything like www.example.com, google.com, whatever, it should take it to the Transit Gateway. Similarly for VPC3. Okay, 10.3 local, but for anything go to Transit Gateway. So far so good. Now only thing we need to do, we need to see or verify is the routing for the Transit Gateway itself. So let's do that. So let me go down and say Transit Gateway. So this is a Transit Gateway, and this is the directly link for route table, but you can also, so it ends with B8. You can also go to Transit Gateway attachments, and let me gateway attachments, and let me see which one is available state, and you see there's a route table B8 for all three attachments, the same route table. So click on this and you go to the routes, and you see that for all these three attachments for VPC 1, 2, and 3, the attachments are already created, route propagated. The only thing we need is to create a static route. So in the brainboard, I have yet to figure it out how to code that, but this, once you download this Terraform files and apply, the only manual step is to basically create this routing. So let's do that. So for any CID range, and I just want to relate, what I'm going to do here is create a static route for that. So, and then it should go to VPC1, right? So let's grab the IP or ID of a VPC1, go to VPC, and I see my VPC ends with 9C8 or 10.1 CIDR. So let me choose an attachment which has VPC 9C8, and I see this is the one with 9C8. Now I click, and before create, let me again go here, and I'm still in 10.3, or even let's say let me SSH to 10.2 here again. Go to EC2, the running instance. Let me go till public subnet for VPC1, SSH this guy. So I'm in 10.1. Let me go to 10.2 on the left. So 10.2, I need to go to private 10.1. Okay, perfect. And then 10.2. Correct. So in both of them, for 10.2 and 10.3, which is for VPC2 and VPC3, I say ping google.com, enter, and ping google.com, enter. Both of them, there is no internet connectivity yet. All I'm gonna do here is go to console and still in the same create static route page for the 000 CIDR, choose VPC1 because I want that this route table for any internet connectivity the traffic should go to VPC1 where we have the NAT and internet gateway. This should provide the connectivity and just say create a static route. That's it. I see that the route has been created successfully. Let's quickly go back to our item and give it a couple of seconds. So let's wait because I've already pinged and it will take some seconds to get activated. All right, I see VPC2 has, we have started receiving the packets. VPC3 also, yeah, all right. So now we see that how using our transit gateways, we can use one of the VPC for all, as a central point for all outbound internet connectivity. And see, it's like very powerful because it can reduce your admin overhead drastically, and definitely it'll help you on saving your cost. And I personally like this architecture, very, very good. All right, so with this is the end of this video, and all I request is like if you like this video, please share with your friends and give me some likes. And if you have any questions and doubts, please ask me in comment, and I try my best to reply some of your questions. And thanks to many of you who have engaged with me and they have asked like not many good questions, and thanks for your help, support, and appreciation.